And so, but more important than Doug's, all of his career accolades is just he's a really, really nice guy, one of the nicest people I know, good friend, good collaborator. I think he's blushing right now in case you can't see. But no, Doug's been a great friend and is just truly a creative inspiration for me personally in a lot of ways. And I'm really grateful that he's come to talk, and I'm super excited to for everyone, and including myself, really to learn about some of the work he's been doing for the past couple of decades. So Doug, take it away.
Thanks, Nabeel. I'm sorry. All right. Yeah, and of course, Nabeel and I have been collaborating as well. And he used to be a student at the Center for Constructive Communication, where I now work. And it's so amazing to see you in your new career. So, okay, so I have like 100 slides, which is a little much. It's a little it's sort of cobbled together from a few different sources, and so I don't think we'll probably not have time for all of the content, but I'm going to kind of go through it fairly quickly, and then leave some time. It's a small group, so I'll leave some time for discussion. I'm just sharing my whole screen because I think there'll be some cases where I actually want to show you some actual like live websites and such. Can everyone see the slides?
Yeah.
Cool. Great. Datamuse, 2 decades of dictionary data science. So the slides are available at that link. The slides have some links to resources and stuff in them. I usually try to give out links to the slides in case they're useful. So I think I've got about 60 minutes, no, 70 minutes of content. How long do we have?
We have 100 or 90 minutes.
90 minutes, okay. All right. But I'm going to breeze through this, so it will probably be more like 60 minutes for this. But so first, Nabeel asked me to talk a little bit about myself. So I took some bio slides that I have. This is like the timeline of my professional life going back to the early 90s. I went to college at UIUC in computer science and then grad school. And yeah, 92 is around when the World Wide Web was kind of coming into its own. I think the protocols were invented in the late 80s, but World Wide Web kind of happened in a big way at UIUC because it's where the first major web browser, Mosaic, was created. So that was a really exciting time to be in computer science. I went to an internship at Microsoft, kind of not knowing. I was just starstruck with Microsoft, so I interviewed there thinking I would be a software engineer, but I found, I met this researcher in speech recognition who convinced me to join his team for the summer, and then ended up doing 2 more internships lasting into my grad school career, doing language modeling for speech recognition. Then I went to Lycos, which it's very possible none of you have heard of, but it was one of the earlier search engines before Google. I left grad school, left a PhD program, kind of hoping that I would get a research topic from Lycos, and there were like a million possible research topics that I could have picked, but like it was too exciting to be part of the internet back then, and I didn't end up finishing my PhD. And then toward the end of 2003, I got an offer from Google, so I moved out to California and worked at Google on stuff like A/B experiment analysis and RCT analysis, and some of the stuff that we do, you've probably talked about in the class. And as well, I worked on voice recognition stuff at Google. And this then went to a startup. After 8 years at Google, went to a startup that was started by a friend of mine from Google. We did machine learning as a service for fraud detection. Did that for about 4 years, and then kind of retired from the corporate world, and am now doing a mix of academic pursuits. But all the while, since 2000 anyways, I had this kind of combination side project company, flight of fancy called Datamuse, and that's going to be the primary thing I talk about. The only thing I wanted to say about my bio, though, is that might be relevant, is that it's amazing. To me, in hindsight, it's amazing how often I've seen the same people again and done the same things, like, done similar. I see the same things over and over again. So, for example, at least 5 times in my career, I've worked on language modeling, which language modeling back in the 90s was, nothing at all like it's like 1,000th to 1,000,000th as small as large as the language models that we see today with ChatGPT. So it was very, very primitive by comparison, but it was exciting then. So I did that as part of my internship, and then also for grad school. So I worked on speech recognition there, and I did it again at Google because I worked on the voice search thing for the phone, and so language modeling was important for that. I do it a lot for Datamuse, as we'll see, and then in my current role at MIT, I work with large language models for and sort of applying them to social science. Search has also been a motif kind of in my career, and I've just been very interested in how information is organized and how it can be made discoverable to people. And most sort of obviously that was relevant for Lycos and Google, but also worked on a search engine for talk radio at Cortico. And then search kind of information retrieval and search kind of comes up again and again at Datamuse. So World Wide Web, everything I've done is related to the web in some way. And then even if I look narrowly at speech recognition, that's come up a few times. The only point I'm making is just that you'll revisit your passions probably many times. And for each of those last few slides, there's like a set of people, and I see those and collaborate with those people over and over again in the last 20 years. So get to know the people you're working with now, because you'll see them again, no doubt. Okay, the next section is kind of talking about Datamuse. I first just going to spend maybe 5 to 10 minutes on the elevator pitch and the mission. It starts with me in the 1980s, and my dad, who's I'm going to be introducing my dad shortly. My dad's on this call, knows this well, but I like to hang out in my room using the computer a lot, but I also really I wasn't like a voracious reader, but I loved reference books, because to me, reference books like dictionaries, thesauruses, rhyming dictionaries, almanacs, these are all, as best I could find them, these are pictures of the books that I actually had in the 80s. They contain, it was somehow very compelling to think that they contain all the knowledge of the world kind of compressed into this portable form. So, I could put in my backpack some representation of all of the knowledge in the world. Obviously, like a very lossy representation, but it was like cool to think, I was captivated by the idea that from a dictionary, you could learn about anything and everything you wanted. Anyways, so a dictionary and thesaurus are probably familiar to some people here who you may not have carried around the actual book, but probably know the concept. Rhyming dictionaries were a thing, definitely a niche thing where you could look up rhymes for words. There were pocket, and still are, like pocket encyclopedias. An almanac is like, a thing that has all of the, I guess it's initially or originally it was for sort of farmers or keeping track of the events of weather and climate and sunrise and sunset, but it also came to be this uber reference tool containing all information about events of the year. And then this thing called a reverse dictionary, which is a way of like looking up words by concept. So yeah, I mean, this is, just kind of pulled a random page of the dictionary, and the dictionary contains many really interesting things like pronunciation of words, how the words function, like they're part of speech, what the lexicographer thinks of as their definition, how they're used in practice, possibly other usage notes, and then synonyms and antonyms. And all of these things interlink together in this beautiful way. And I guess, and my mom had this, or we had this unabridged dictionary on wheels in the house, and it just kind of fascinated me to think about how that stuff was all linked to each other, how all of the entries in the dictionary were linked to each other. First English dictionary, 1604-ish, but dictionaries and reference tools in general, word reference tools in general, were mostly books through the 1980s. None of us, you would remember this, maybe not even you, Nabeel.
What about floppy disks?
What, you wouldn't, yeah, the dictionaries wouldn't fit typically on floppy disks. So we didn't really have things like Encarta and other encyclopedias until the CD-ROM era of the 1990s. And then, you know, in the late 90s, 2000s, websites emerged that did some of these tools. And then, of course, by 2010s, we had mobile apps. So that's kind of a brief history of how we look up words. But essentially, these four categories or these three categories are just digitized versions of the books. And that always seemed a little unsatisfying to me, except I guess arguably, you know, Google is not a digitized book, but the dictionary part of Google is basically just licensed content from one of these dictionaries. So it didn't feel to me that really like used all the capabilities of computers in a reasonable way, in a good way. So computers, you know, what they offer over a book, well, many things, but I mean, one, you know, obvious thing is that there's no limit. There should be no limit on what you can look up, right? For example, I'll just pick on Nabeel. You probably won't find the word Nabeel in the rhyming dictionary, just because, you know, no offense, but it's like not a common enough name, at least in a U.S. English context, to maybe warrant an entry. But the word Nabeel is a totally reasonable thing to search for in a rhyming dictionary. So, or anything at all, or any word or phrase, or maybe I want not just synonyms for simple concepts like happy and sad, but perhaps I want other words that mean that thing that hangs in the back of your throat, right? And so maybe I can, you know, a traditional thesaurus would not let you look things up using that kind of, you know, flexibility. Also, comprehensive output. There's no limit to how much you can show. You can organize it and filter it and cross-reference stuff potentially in many more ways on a computer than you could on in a book. And you can customize the content to the user's context and to the moment in time. Like maybe you could show lyrics from you know, a play that a musical that the user is interested in or that's running at that time, stuff like that. All these kinds of things are possible, but are not possible in book form, but are on the internet. And so Datamuse, I guess, if I had to capture, this is sort of my official mission statement for it, is a collection of websites, mobile apps, and APIs designed to help people create and communicate more efficiently. Aim to organize knowledge in ways that inspire, inform, and delight people, making everyone who uses our services a more effective writer, researcher, and learner. I was really like hooked by Google's mission statement to organize the world's information and make it universally useful and accessible. So I thought that the company needed a mission statement of that kind of like ambition. So I, you know, with my dad, who's on the call, hi, Dad. We started. Oh, sorry. I just want to explain the name a little. It's this four-way. It sounds a little cheesy in 2023, and actually, to be honest, it did in 2000 as well. But it's this four-way portmanteau because meaning it's like four words jammed together. But the sort of trio of goals of the company are to inspire, inform, and delight, and use is the inform, and inspire, muse is the inspire, and delight is the amuse. So yeah, that's the reason for the name. Yeah, so my dad helped me with all the administrative stuff and getting it started, and has worked very hard over the last 20 years, continues to work on the sort of financial side and on the administrative and customer support side. But it's not a normal company in the sense that there are no employees or factories or anything like that. I kind of call it a venture. It is technically a for-profit company, but it's also, but it's you know, there are no full-time employees, and it's just been me and my dad part-time. And then I also hire and work with contractors and co-op students over the years. And these are, apart from me and my dad, all of these folks are contractors or students that we've worked with. Okay, I'm going to skip past the timeline, but mid-90s is kind of when the rhyming dictionary that became RhymeZone got its start. And then I incorporated Datamuse in 2000. And then, yeah, we'll go through some of this stuff later. Okay, so that is overview and mission. Here's what we do. These are the kind of products and brands of Datamuse, but RhymeZone is the one that's probably most familiar to people, especially if they grew up in the 2000s or 2010s. RhymeZone is a rhyming dictionary, thesaurus and lyric search website. Started by some measure in 96, but only really kind of got going in 2000. What I think surprises people is that it sounds almost preposterous that such a small niche application like rhyming dictionary would be popular, and it you know, the internet's so large and there's so many people that small niches like operating a rhyming dictionary end up being big enough really to sustain a business. So we get still to this day about 1 million to 1.5 million, sometimes as much as 2 million queries per day, about close to 500,000 users, 7 million unique users monthly. Definitely nothing approaching Google scale or even ChatGPT scale, but pretty constant over the years, very slow growth, probably hit its peak in the pandemic and has declined a little bit since then. Mobile apps for sale. Otherwise, the website is kind of based on sort of the main revenue for the company comes from the banner advertising on the website. Somewhat neglected. I was planning to do work on kind of a major redesign of both the form and function this year, but owing to current events, it's unclear if and when that will happen. Romario is the Spanish version of it, which is much smaller in terms of scale, but it's was partly a vehicle for me to learn Spanish. Arguably still can't speak at all, but it was a helpful exercise. It's actually grown quite a bit in the last couple of years, which is mysterious to me, but its main audience is Spanish speakers in the US and also Mexico and South America, not continental Spain. OneLook was a much more popular site in the 2000s, but it's a dictionary search engine that indexes words from 1,000 glossaries that it spiders on the internet. Actually started by another guy, and then kind of my dad and I purchased it and revamped it in 2002. It used to be a lot more popular because it was one of the main ways people looked up definitions before Google got really good at handling that. And then OneLook, and then also the kind of category leader in dictionaries, which is dictionary.com, both declined a lot since then. But it's still used for certain features that are unique. Like you can look up words by wildcard, which means if I only know some of the letters, I can see all of the words that match those letters. And then there's this reverse dictionary, which I'm going to talk about a lot later. And the company also makes an API, which is used by educational apps, some like tutoring systems, games, search interfaces, and brainstorming tools. It's effectively all of the functionality of Datamuse that I kind of factored into an API service back in 2015. And it's pretty popular in the sense of a fairly large number of random small tools, lyrics tools, and writing tools, and domain like naming tools, and sort of a big ebook publisher uses it to do things like autocomplete or to help people brainstorm ideas. Some of these applications probably over the next year or two will probably switch to using ChatGPT, so we'll see. It is a free API though, so it doesn't affect the revenue of the company if they leave. I'm going to skip this slide, but it kind of tells what the basic form of the API is that you can specify constraints, a set of constraints, and it finds all of the words that match the constraints so that you can do things like show me all words that are related to duck that start with the letter B. I'm not actually sure what I had in mind for that. Were related to spoon and end in the letter A. I guess this was spatula. You know, you can kind of get the idea. Different combinations of constraints. If you're looking for words, you can use the API to find the list and then use it in your app. Probably the thing that I'm keenest on is called OneLook Thesaurus, which is part on the OneLook domain, but it's kind of a separate site. It was first created as a feature of OneLook in 2003, and now it's kind of this separate thing, which I put a lot of energy in last year. It's also syndicated on Rhyme Zone and on there's a Google Docs helper and other stuff. But it's kind of, this is effectively the major research focus of the company now, and the goal is to be the best kind of word finding tool, best thesaurus in every language, and sort of a starting point for exploring and brainstorming ideas. Oh, that's weird. Oh, shoot, I should not have made this animated. Yeah, by far, like RhymeZone's the best known brand, but I feel like the OneLook Thesaurus gets the most kind of interesting, like the most wow reaction for a much smaller group of people. But those who this is all just praise from Twitter. I should not have put this on. I like monitoring Twitter for mentions being, I guess I'm sort of narcissistic about Datamuse. But yeah, lots of like every day, well, every few days or so is one of these like excited, oh wow, this is really helping me find words. And last year I was really proud to be selected or mentioned in the major the National Aphasia Association, aphasia being a cluster of lexical retrieval disorders, as kind of a helpful tool for that community. And we have heard from people with aphasia over the years, so it was nice to be recognized for that. So OneLook Thesaurus is kind of like embodies this idea of like unrestricted input and comprehensive output. You can do things like, you can do the usual like kinds of lookups you would do in a thesaurus. I'll just click on one just to, hopefully this won't disrupt things too much. I can say like, look up something like joyful and see its synonyms. And then when I see its synonyms, it will show me information about the word and how its usage history and some usage examples and stuff like that. So this is an example of the kind of basic things you would do with a thesaurus, although unlike a traditional like book thesaurus, you can also look up entities like say Lake Ontario, and it will tell you things that are similar or related to Lake Ontario. So that's a class of like conceptual queries, meaning show me things that are similar to this concept. And then there's like what I call descriptive queries, where you describe a word that you may know exists, but you've forgotten, such as that weird thing that hangs in the back of your throat, which hopefully, yeah, gives us uvula. And then there's this other minor class of queries called enumerative queries, where you're looking for a list of things like maybe I want other ways of saying squishy, spongy, and gooey, but that's the only way I know how to describe it. So you get really hundreds of other ways of articulating that, or maybe types of soft cheese should give me, yeah, things like brie and camembert and then a bunch of others. Okay, so that's the kind of queries that OneLook supports. There's so many interesting problems in creating a thesaurus, like picking the most, I guess the core problem is finding the synonyms and related words for what people type in. Showing which ones are best for different writing contexts, like maybe you're writing fiction or a legal document or jokes. Showing who has used the word, where and when it's been used, in what context. Picking the most interesting examples, the best definition to use, which sense of the input the user intended, because sometimes it can be ambiguous. With even things like what's the right casing, you can really geek out on, because there's a lot of nuance there. And then other more brainstorming related challenges, like how can I show other topics that the user might consider? How can they find more examples of things, and how could I integrate, for lack of a better term, encyclopedia knowledge, like information about places and people and things. So I'm not going to spend a whole lot of time talking about the sort of technology stack. This is a slide from another presentation I gave to the co-ops last semester. But at a high level, there's three areas of software engineering. The first one is called ETL. ETL stands for extract, transform, load. It's the old term really for data science. The term data science didn't exist until around 2009 or 10. So it's still not the way that kind of I describe the concept. ETL just refers to taking data from databases, munging it in some way, and then loading it into a tool or some other software program. Most of the interesting work, I'd say, for Datamuse is in this area. Primarily, I use Python and libraries that you may be familiar with from your class exercises here. The API, which is the kind of engine that serves the knowledge, is a big Java application. Probably still my favorite programming language. Front end is the other kind of part, the other third of the company, and that's things like the websites, apps, add-ons, anything where you're actually dealing with the end user. And front end tools are written in a wide variety of different languages. Do a lot of work in JavaScript historically through the jQuery library, but more recently been doing React applications. The iPhone app is written in, one is written in Objective-C and another is written in Swift. And then the Android app is in Java. So these three pieces kind of interact with each other in the sense that the ETL layer is where we gather all of the information from data sources. It makes it available to the API. And then the API is used by those third-party applications I showed earlier, but it's also used by Datamuse internal tools. And so ETL, just to give a flavor for the kinds of things that we have done in the recent past, how do we pick the best usage examples for a word? How do we find a sentence from Wikipedia that best defines the topic of the article? How do we determine which aspects of a pair of rhyming words make it interesting? We'll be talking about that one. Clustering text in different ways, using Google Books data to determine which words are outdated. Yeah, so I'm not going to spend too much time on this, but because we'll be talking about some of that later. Skip past these two slides because they're not that interesting, but we've made in the recent, like last year, made a new iOS app for One Look Thesaurus and an idea map visualization in Google Docs, and done a little bit of work on internationalization, although it was my kind of intent to do a lot more. So that's the portion about kind of our products and software stack. Should I stop? And by the way, if you guys ever, if you have any questions, either remote or local, you can either break in or we can take them later. Oops.
No questions, but I definitely use Rhymezone a lot.
Okay. Oh, cool. Yeah, I'd love to hear about that maybe toward the end.
Get all your user feedback.
Yeah. This is actually going to turn into a user study. So now this is, I guess, the meat of this, and that is because Nabeel asked me to talk about data science. So we'll be talking about data science. So there's four. I was trying to find like exemplary kind of applications of data science in Datamuse, and a lot of them are machine learning related. And I picked 8 interesting, what I thought of as interesting applications, divided into 4 different sort of themes: sequence models, regression models, embeddings, and large language models. And I'm guessing that the large language models and embedding stuff is probably of most interest to people. So I'm going to speed through the first 2. Okay, so for each of these, I've dedicated 4 or 5 minutes, and we'll just kind of go over the motivation, and then what we did, and then sort of a recap. Just get this chat thing off of my. Okay, so sequence models. The sort of exemplary task there is just going to be like, how do you pronounce a word? There is within NLP, there's a problem called the graphemes to phonemes problem, which is a pompous way to say letters to sounds. Technically graphemes can be more than letters, so that's why they don't say letters. And technically sounds, phonemes can be more than, or aren't as simple as just sounds. But the problem is, how do we take a word and convert it into a representation that a computer can use? And so if you've had some exposure to linguistics, you may know that word pronunciations are typically represented as a sequence of what are called phonemes, which is an alphabet of sort of sounds that made by the human voice. In that alphabet generically is kind of supposed to represent anything that any human might say in the so-called International Phonetic Alphabet. Here we have a different representation than the International Phonetic Alphabet. It's a ASCII representation that's called ARPAbet, but each of these little chunks is like a little sound. So theta decomposes it into the th sound, the a sound, the t sound, and then similarly data. Here's a journal, and then here's the really irregular one, kernel. In this representation, one kind of tell you where this lexical stress is placed on the word, like what you emphasize. So it's theta rather than theta. And then the 0 tells you where the weak stress is. So we have this problem of like going from the word form to the phoneme form, and that's what's called the graphs to phones problem. And in the old days, you would build, I wanted to. The reason it's important, or one reason it's important for something like RhymeZone, is that we have to do this in order to know which words rhyme. So theta and data rhyme. You could probably guess that just by saying them out loud, but the sort of technical definition of perfect rhyme is that everything starting at the most stressed syllable going forward is the same. Everything starting from the vowel of the most stressed syllable going forward is the same. So theta and data are rhymes, journal and kernel are rhymes, and then Nabeel, sorry, you don't have any rhymes on here. Sorry about that. I don't know why I picked the example that way. So that's just a motivation for why we would need it. There's a lot of human labeled, like, linguists have poured over dictionary. When you use a dictionary, you probably notice the pronunciation in IPA or some other representation. So there's been a lot of work to transcribe the words for language like English phonetically. There's a so-called CMU pronouncing dictionary, which has about 130,000 of them, that lots of people, probably literally thousands of applications over the last 20 years, owe a huge debt to this dictionary, because it's probably the main public domain source of this knowledge. But even a big dictionary like CMU is necessarily limited, because it won't have brand new words, like maybe COVID is probably missing from the CMU dictionary. It won't have rare proper names, like Gillani, sorry. And there's no single resource that could possibly contain everything that a human might say. So we need some way of producing the phonetic transcript for words that aren't in that set. So I'll just quickly look at two things that we've tried. One is a method from the 2000s called joint sequence models, and then from the 2010s we have neural models like LSTMs and CNNs. And it won't go into really any technical detail because not enough time, but joint sequence models are basically like a way of decomposing a training set into kind of pairs of letter sequence, phoneme sequence sequences. So this is, unfortunately, this is written in IPA rather than the symbol set that I just showed you before, but one graphone, as it's called, is a letter M paired with a sound M. Another graphone is a letter I paired with a sound I. Another is the letter X paired with a combination of sounds K and S, and then in I and D. So a joint sequence model is going to learn over a data set like the CMU pronouncing dictionary, will learn all the possible combinations and then find the most likely sequence. Given a new word, we'll find the most likely sequence using what's called the EM algorithm, which I'm not sure if you guys done EM algorithm. So there's a link there, a lot more details. This is the kind of competing way to do it, and the more recently would be with neural nets. And generally speaking, you know, all of the models have the shape that there's an encoder and decoder. And what form the encoder decoder takes varies, but the most recent work in graphemes to phonemes with neural nets uses CNNs, which we won't talk about, but it's a pretty simple recurrent model to or convolutional model to do letters to phones. So I'm just going to say that what we ended up using actually, and what we still use at Datamuse, is this joint sequence model rather than the more modern stuff. And that's because, well, okay, so English, complete basket case of a language when it comes to spelling, because it's this, you know, mongrel language that draws from all these different sources, and the spellings, of course, have changed over the centuries. And they weren't even really conventional until the last 200 years. And so English spelling really warrants a fancier model. Spanish, on the other hand, and other more Romance languages often are predictable enough in their pronunciation that a very simple rule set suffices. So that's, in order to handle English, is the only reason I kind of need to do all this stuff to begin with. But even within English, there's not just one English. There's US English and Canadian English and UK English. There's Boston English versus New York English. I mean, within New York English, there's Brooklyn English versus, that's right, sure. So we have, even the methods that I've considered don't really handle that dialectal variation in a very satisfying way, unless you have specific training corpuses for each dialect. So my one learning from this project as a whole is that just neural models do make weird errors. Here's a case where if it gets like a sequence of consonants like MVP, it doesn't, first it has this catastrophic error, as they would say in neural models, like it just goes off the rails and just starts spitting out EH sounds, whereas the JSM model gets it more or less correct. And even though I think by some measures the neural model may have higher accuracy, in the aggregate, the errors were too weird, and they're kind of close enough in error rate that I ended up keeping the joint sequence model. But the main lesson there is there's lots of valuable work from the, going back decades that is unfortunately getting sort of overwhelmed by all of the new neural models that have come out recently. Next, we'll just talk about uses of regression models, which I think you've all talked about in the course. And although I say regression models here for these next three applications, other simple machine learning algorithms like SVMs or decision forests would work as well. There's nothing inherently, I chose regression models so that we can kind of see the feature contributions more clearly. But it's not really specific to regression models. The next slide is kind of this, the next task is finding the right best usage example for a word. And I want to start with a little interactive portion. Who here knows what the word, already knows what the word sartorial means? You do. Oh. Yeah. Well, not the sense that I meant, but I wonder if that's also the way that you would say of Sartre. It could be. It could be. Yeah. Do you know what the comment? Yeah, this is a rare enough word that I'd hoped to get 0. But now I'm going to show you one usage example, which is sartorial elegance. This is what actually is shown if you search for sartorial on Google. And so maybe now you're starting to get a better sense of what it means. If you click on a little thing on Google, which says, show me example sentences, it will show you, they accused him of having poor sartorial taste. So you might still get some sense now, slightly better sense of what it means. Here's what it is on one look. The example that's shown for one look, thesaurus, is the musical success prompted a brief sartorial revival of 1920s fashions by dress factories. So now, hopefully, that's kind of enough information that even if you didn't know the sort of formal dictionary definition, you might still get the sense that it's something to do with clothing. And so the meaning of sartorial, or at least the sense that I had in mind, was of or related to clothing. Oh, okay. How do you say? I'm wondering how you say related to Sartre, like Sardish? No, Sartre-like. So this project is about using preference data to select those examples. So we started with a data set of famous quotations and a set of words from SAT practice tests, and then roughly 2,000 times we picked a random word and then 2 different quotes containing the word. And then for each pair of quotes, we asked a rater, like a crowd worker on Mechanical Turk. Have they done anything with Mechanical? Okay, so Mechanical Turk is this Amazon system for doing labor. Like if you have like a task for labeling or annotating a data set, you can pay people to do that work for you. But in any case, we took these pairs of sentences and asked people which one do they think is a better usage example, and then ran did a regression model to identify what features of the sentences, what are the features of the sentences that win. And then I'm sorry, I just kind of like copy and pasted some terminal output here, but the high level summary is usage examples are preferred when they contain other words that are semantically related to the target word, but are short, syntactically simple, and contain the target word early. What that means is, what I mean by the first thing is we have other words in the example, in this case, fashions and dress. You could see from a word embedding, you could see that those two, if sartorial means related to dress, then the distance between dress and sartorial is likely to be pretty small in the word embedding space. And so we can kind of programmatically see that this sentence has a lot of other evidence for the word that's being defined. Whereas by contrast, this thing, sartorial elegance, well, it only has one other word, and elegance is probably pretty distant from sartorial. So all that is to say, I've like cherry picked one example where I think our system does a better job than Google's, but it uses this insight that that we found from this regression analysis. So we want words that are semantically related to the target word, but at the same time, the sentences need to be short, which is kind of in tension, because the more words that you put that are semantically related or unrelated, the longer the sentence is. So you want a compact sentence that nonetheless has like a little bit of extra support in this way, and they should be syntactically simple and contain the target word early. In practice, what we actually pull data from quotes from Wikipedia, from a data set called Project Gutenberg, which has books that are out of copyright. And we use the ranking function that arises from this regression as a default sort ordering for examples that are requested in the API. And I just want to point out that we're we collected this data and asked people which examples they prefer. It's not the same thing as necessarily how useful they are, like whether they're helpful for learning vocabulary or retaining knowledge. And so that's something that would have to be tested in another study, or that I kind of hoped to do when we undertook this back in 2020, but haven't gotten to it yet. So application 3, I just want to do a quick time check. Okay. Yeah. Funny words related to X. Okay. This one's kind of fun, hopefully. So some research in computational humor, which is a real thing, has identified that certain words are inherently funny, like context-free, like just mentioning the word in isolation makes people laugh, or at least lightens the mood. So I've given some examples of words that lighten the mood, like hippocampus. I mean, isn't that hysterical? Hippocampus, this is from sort of a humor theory, like why it's funny. Hippocampus might be seen as funny because it's this weird juxtaposition of hippos, which are kind of funny looking animals, and a word that we probably don't expect to see next to him, campus. Nincompoop, it's kind of a funny word. I don't know if anyone uses it still in 2023, but it means like jerk. But it might be funny because of the poop part of it, which is scatological humor is always good for a laugh. Yeah, having to do with scatology. I'll let you look it up. Yeah. And then other words are funny just because they have like fun sounds. I think they found that just the Z sound is a mood lightener. So just if you want to, lighten the mood, just add some Z's to your emails. Sometimes things are funny because they're just extremely informal. They're unexpectedly informal, like a gab fest as a word for a conversation. Anyways, there's been a lot of past research on humor. Engelthaler Hill 6 years ago asked a bunch of raters to judge a bunch of like 5,000 English words for humor. And then more recently, my friend Adam Kalai, with a student he was working with, Gulchin, used that data to train a model that predicts humor from any word. So you can give it any word like Nabeel, and it will tell you whether it's funny or not, based again on an embedding model. And that model is then used to score a much, much larger word that, vocabulary of words, as then kind of takes its form as or sort of manifests as a sort by funniness feature that's on Look Thesaurus. I just want to point out that the paper, it's a funny paper because the title contains funny words in it, cockamamie, gobbledygook for nincompoops, none of which are words that are kind of in fashion, but they would have been back in the 1950s. And they actually had to, the paper it's a fun read because it has lots of other funny words, including words that are funny for, that are insulting or sexual humor or scatological humor. And so they actually had to put this warning on it. So I thought that was kind of funny. I've never seen a paper with this kind of warning. Anyway, so yeah, if you type in conversation and sort by funniness on one look, you'll get like gabfest, confab, banter, slangwich, chit chat, or like perfect, you'll get cromulent, cocksure, a-okay, groovy. These are, it's just we added this sort feature as a way of helping people find words that fit a certain mood or theme, and funny sounding seemed like a natural extension. But the lesson for the project, I think, really for me was that word embeddings just encode a surprising amount of knowledge. I didn't really describe this model that Gulchin did, but it was really simple because it just regressed the 300 dimensions of the word embedding vector to this humor, the humor rating. It didn't use any other features, just the word embedding. And even though we think of word embeddings as being kind of just about meaning. They also encode humor in the sense, sort of accidentally, and they even encode sound in a certain way. And so, yeah, you can get a lot of value out of but this is an incomplete quote, but we implemented this and sent it to the authors of the paper, or pointed to the authors of the paper, and they were delighted. And they said that of all of my papers, this is the last one that I ever imagined would be implemented in practice. So thank you, which I guess was a compliment. Task 4 was about rhymes. So I was looking for more up-to-date examples of this, but when you search on a rhyming dictionary, and let me just actually show what that kind of looks like. Oh, wait, no, hold on a second. Sorry. I can't reach my, we give this, we can actually do this with the word forest. We give this like ranking of words on Rhyme Zone with a sort of a so-called rhyme rating, and by default it's sorted so that the most rhymey words are first, like so-called perfect rhymes. That's again where that phonetic transcription matches. And so, but we kind of always wondered, is this the way that people would actually, does this actually prioritize the rhymes that are actually interesting to people? So we take a word like forest and we look for examples of forest. Actually, there's a way to do that on Rhyme Zones. Let me just show you. We can kind of see lots of people rhyme forest with sorest in songs, and but the kind of like the most popular rhyme is actually chorus. Forest and chorus are not perfect rhymes, though. If I showed you the phonetic transcriptions, you would see that chorus doesn't have that T sound, so it doesn't match. But nonetheless, it's way more popular a choice than something like sorest, which is a perfect rhyme. And so the question is, what drives people to choose rhymes, and what aspects of the sound elicit? God, I didn't finish this. What aspect of the sound kind of drive people to choose one choice over the other? So we did a very similar kind of thing to the usage examples thing that I just showed you, which is that we generated a bunch of triples of words. So word 0, word 1, word 2, where word 0 and 1 and word 0 and 2 are both like plausible rhyme pairs. So an example might be forest, chorus, and sorest. And then we ran a survey, a larger scale survey than the usage example one, because of an easier task, where we showed one of these triples to people randomly and asked them which pair they prefer. And this is kind of what that looked like. So we just asked people 10 at a time. We'd ask people these questions like, would you imagine that it occurred in a song or a poem? What word do you think sounds better as a rhyme? And sounds better could be, they're not seeing this in the context of a poem, so it's a little abstract, but we're asking them to kind of imagine it in one, and they could choose one or the other for many different reasons. We wanted to see what all those reasons were by just asking enough people and then running a regression. And the regression we ran used features of the vowels, the consonants, the stress pattern, how popular the words were, and the semantic relationship. But this is sort of a failed experiment so far, because the models that we've been at least tried so far are very, very bad at predicting preferences. Or another way of saying it, at least the preference data seems noisy. There's a lot of disagreement even within for a particular rhyme triple. It's surprising how much variability there is in what people choose, but also we don't seem to have the factors that drive preference, because the model that we have, which use a lot of the features that we could think of, give us an R squared of 0.15, which hopefully is like not very good. And actually, it turns out that only one feature, which is this phonetic distance, like how close together are the sounds, drives most of what little we're able to predict. When it's the only feature, when it's the only feature, we get almost the same R squared. So we have, yeah, it's work in progress. There's other features to consider. We've also kind of like looked at this from the lens of lyrics data, or what's been written, rather than asking people what their preferences are. Let's look at the collective wisdom from songwriters from the past and say, do the same thing where we pick these pairs, but then kind of ask the question, which pairs are more frequent in the lyrics data? Doing that, you get something that's much more predictable, still fairly low as these things go, but we're able to kind of model past choices pretty well. Not what people express to be interesting, which actually may say something about the sort of predictability of what's been written versus what people kind of want to hear. Okay, 5, I guess we're sort of halfway through our set of examples. Other words, okay, we're now going to talk about embeddings and then large language models. For our embedding section, one of our motivating tasks is, what are some other words like these? You may recall I had an example of enumerative queries when I introduced one look thesaurus. And in that example, I think it was like squish, gooey, whatever. I'm using a slightly different example here for illustrative purposes, but suppose you're looking for things that are like two-wheeled vehicles. And you could actually just say two-wheeled vehicles and maybe it would do the right thing. But another way of expressing it is just by naming a few, like tricycle, bicycle, unicycle. If I do this, hopefully I get the right thing. Yeah, I get a bunch of different bicycle-like things. And here's how it works. So you're familiar with word embeddings. Now, imagine a particular word embedding model. We project the word vectors from that model into a 2D space, and we plot them on a scatter plot like this. And you can imagine our unicycle, bicycle, tricycle are three of those three of those dots, and then we have other things. Kind of the stuff that's nearest to those would probably be other biking related words, and then farther afield we have other vehicle related things and so forth. The thing we want, you've probably done things like, what are the nearest neighbors in a word embedding? And so one way to solve this problem is to say what's closest to one of, like the first thing that I mentioned, tricycle. The problem with that, at least for this application, is it's not what the user wants. The user doesn't want terms related to these three things. They actually want other instances of this category of things that's defined by the three things. So this approach is useful in some contexts. So you might say, okay, well, let's try to represent these three things in some way, maybe by taking the centroid, but that still doesn't work, because like the centroid here might be something that's close to bicycle, and I'll still get things that are not of the category bicycle, unicycle, tricycle. What I'm really looking for is something that gets scooters and motorbikes and motorcycles, these other two-wheeled vehicles. And there's a lot of different approaches to doing this that we've toyed around with, but one way of casting the problem is saying, like, what are the points that are nearest to any line that's formed by any pair of the seed set members? So you can imagine projecting different lines from, I haven't shown it here, but like projecting different line between bicycle and tricycle would pretty nearly fit scooter, motorbike, and motorcycle. And so those three would, by this metric, be seen as closer than the other stuff that we looked at. So this is a really important, within Datamuse, this concept of expanding a set of seed items is important. It's used to kind of backfill, like produce more results for reverse dictionary queries, which we'll look at later. But it's also just a concept that seems to come up a lot. Formally, I think people call this the problem, the vertex nomination problem. And there's a lot of different ways to do it. None that I've seen applied to this specific case of like running a thesaurus. There's a couple of gotchas. Just want to point out. Basically, in practice, if you do something like this and then you release it to the world, and then you'll find that it breaks down for reasons that you didn't anticipate. And one of those reasons is like, well, you can't really just use context-independent word vectors because in general, words can have many senses. So if I did Jaguar, Mustang, and Chevy, well, Jaguar and Mustang are both animals, and so I'll probably end up getting a lot of animals in my set. But probably what's intended by this set is, because there's 3 brands of cars, so it should bring up cars and not animals. So really in practice, on one look, we don't do word vectors. They're actually sentence embeddings that are formed from a word senses, but that's a detail, I guess. And yeah, and then we evaluate this as with everything we do. In this case, on a manually curated set of seed sets and what terms are expected to be found in their expansion. Okay, and the next application, now moving from like word embeddings to sentence embeddings, I'm going to talk about this thing that's called Spruce, which is a feature on one look. Sometimes you want to know, what do other people think about this? I think interfaces like ChatGPT are all about like, write this thing for me. And that's one view of writing assistants. A view that I'm more interested in is how have other people spoken about this topic before, and how can I cross-reference to ideas that are similar to what I've written? And so long ago, I guess really just 3 years ago, we worked on this quotation finder, because searching for quotations on the web was kind of a mess. Well, it still is. But conventional quotation search engines are keyword based. So if you're looking for quotes about a topic, you just type in your keyword like you would, or you probably just go to Google and you find it on some quote site. Often they're kind of garbagey. Has anyone experienced this of looking for quotes? The idea here was to make a quote search engine that's kind of more about the theme that you've typed in. So we did this thing called Spruce, which we tagged a inspiration search engine, a little bit bombastic, but it takes the form of a Chrome extension and also a standalone website. Here's how it kind of works. The idea is that if you're writing a letter, here's an example of a letter that some people wrote recently. You may be familiar with it from the news. The "We need to pause AI experiments" letter. You can imagine if you wrote this first paragraph about AI systems with human competitive intelligence can pose profound risks to society and humanity. You can imagine you're writing this, and then you're like, okay, what do other people think about that concept? You could just enter the whole thing into Spruce or highlight it on the Chrome extension, and then it will dig up these related quotes. So I think this is a very good, very relevant quote from Stephen Hawking. I'm not so sure about the first one, but the second one is, "Success in creating AI would be the biggest event in human history, but unfortunately it may also be the last unless we learn how to."
Sam Altman really say that?
Yes, he's been like mercilessly requoted like for this. AI will probably most likely lead to the end of the world, but in the meantime there'll be great companies. That's something this is the CEO of OpenAI who is leading us into this future.
When he said that?
Yeah, it was like 2017 or something. It was kind of tongue-in-cheek though, so it's a little unfair.
Yeah.
The way it's getting replayed is a little unfair. I mean, he's very worried about like he is sincerely worried about AI safety, so I don't think he's laughing off the issue so much, but it is a funny quote. Yeah, so the way Spruce works, crawl lots of data from the web, assembled into these databases on quotations, lyrics, jokes, proverbs. Oh yeah, it's also it can be a fun, Spruce can be a fun joke finder too, by the way. And unlike ChatGPT, it will not hallucinate things. It will only give you things that have actually been said, although sometimes the attribution is not correct. source attribution, like if you're dealing with stuff on the web in general, is hard. Because although a website may say that Mark Twain said that the coldest summer he ever spent, right, the coldest winter I ever spent was my summer in San Francisco. That quote is like attributed to Mark Twain. It's attributed to a lot of other people. No one really knows who said it. Quote attribution in general is hard, but the web the way quotations websites have propagated over the last 20 years has muddied the water even further, I'd say. Released this and then found that, well, lots of people, not enough people are like actually copying and pasting their text into this thing. They still prefer to search just one or two words. So unfortunately, the system as architected doesn't really work well for those kinds of queries. But also learning is that people don't like to install extensions unless they're vital. Almost everyone who uses this, a pretty modest number, but almost everyone uses either the website or the Google Docs extension. Okay, so we're almost at the home. What do we got to 1:15? We got 30 minutes. Okay, all right. I'll power through these. 7. We're now going to look at large language models. So we're taking us to the present day in technology. Both of these applications use OpenAI's GPT API. So the main sort of like my most treasured problem in all of computer science is probably this like reverse dictionary problem. How do I take a sentence like that thing that hangs in the back of your throat and recognize that people are talking about uvula, or maybe if you type feeling of intense longing, you get lots of different synonyms like yearning, craving, desire, and so forth. So this is now a studied problem since like the mid 2010s. This is a problem in natural language processing called the reverse dictionary problem. But before it was that, we proud to have produced the web's first reverse dictionary back in 2003. Back then, it was based on really simple information retrieval techniques, meaning it just indexed dictionaries and did queries on the dictionaries with a little bit of like synonym expansion and a few other tricks. Improved it over the years and maintained it as state of the art try to kind of keep it humming along. It didn't really have any kind of competition per se. It was the only real site out there that did this reverse dictionary thing until mid 2010s. Felix Hill and then Yoshua Bengio, one of the godfathers of deep learning, published this paper called Learning to Understand Phrases by Embedding the Dictionary, which was the first neural model applied to this problem. Then I, having read that paper, quickly went and investigated using word embeddings and other neural models in reverse dictionary, but actually didn't. I was going to say, an interesting fact is that this paper uses OneLook, and several of the papers from the late 2010s use OneLook as a baseline. And this paper, at least in 2016, didn't really beat OneLook. They just sort of achieved around the same accuracy for certain classes of queries. So
they did a bunch of fancy stuff.
Yeah.
And your stuff was not super fancy, right? Like it wasn't.
Yeah, it was pretty gross, but it had been refined over 15 years with like a lot of just a lot of it just handled a lot of edge cases and such. So but I knew then that these neural models are worth investigating. I tried to you apply some of what I learned from that paper and the next few papers to improve the service, but I never actually could beat. For a long time I just could not beat my own baseline. So not well sort of it's both a brag and also I guess this, because I actually wasn't able to transfer even some of the things I learned in those papers to the results that they were getting until GPT-3. And so for GPT-3, holy cow, like 2021, the API became available in 2021, and then one of the first things I tried was just ask it, give it like a description, give it the description the person enters and ask it to list the word. And you can do this like in a 0-shot fashion where you just say like, what is a word that means feeling of intense longing, and it will work reasonably well. But even that didn't quite beat the baseline. What beat the baseline was to do a few shot thing, what you see here, which is like take a few well-chosen examples, enter this, you can imagine this is something you would enter into ChatGPT. Take a few examples, and then take the query of interest, the one that the users entered, and then and then sort of tune the instructions a little, pick the examples wisely, format the input query, and then the answer that comes back is likely to be right. And how likely? Actually, I guess I'll get to that in a second. But this actually was a little deflating in a way, because it almost took the joy out of like making the reverse dictionary algorithm. If now you can just like ask this thing to do it for you. But there's still a lot of problems associated with productionizing this. So for example, maybe I get those four back from the language model, but then with one look, I want to be able to show many more. I want to show hundreds or up to 1,000 results so that people can search and sort and filter. How do you do that? That's something that we talked about a few tasks ago. Yeah, I keep this evaluation set, which has like queries that people make repeatedly, like what do you call spot on dice? Little spots are called pips. Certain crossword puzzle clues kind of come up a lot. Completely randomly chosen queries from the logs, like mild word, which is a substitute for a harsher word, euphemism. And then there's some lists out there of like really known difficult words that people hardly ever use, but when they do, it's to mean some very specific thing, like condition of finding it difficult to get out of bed in the morning, dysthenia. Anyway, so I have this evaluation set. It's only up to about 400 examples that I've kind of hacked on over the years. Not great practice. You probably want to like change your evaluation set frequently, but I haven't. So the accuracy at 1, meaning the probability that GPT-3 gets the right answer on the first right answer, is about 80%. So there's still actually a lot of room for improvement there. So this is not.
Compared to the OG algorithm.
Oh, the OG one was probably in the 40s.
What?
Yeah, this is like such a like it, and all at once too. Like again, all that BERT stuff kind of just added a few percent, and then the large language model is like almost jarring. But I also measure the accuracy. Accuracy at 100 is like how likely is it to get the right answer in the first 100. Okay, last application, and we can discuss what do these words and phrases have in common. Yeah, okay, so we go back to the original thesaurus, or at least thesaurus as intended by Peter Roget, who was the guy who created the thesaurus that we all know and love back in the mid-1800s. His thesaurus wasn't the kind of word lookup thing that we use now. It was more about organization of words into categories. So his original, as it's called, thesaurus of English words and phrases classified and arranged so as to facilitate the expression of ideas and assist in literary composition. That was the full title of the thesaurus. So he needed a he needed a summarizer, I think. That work, which inspired the kind of pocket thesauruses that were popular in the up to the 80s and 90s, was more about producing categories of words. So like there were about 1,000 categories in this thesaurus and about 15,000 words. So maybe on one page you'd have this reasoning category and then all of the words related to reasoning. So it intrigued me to how, if I were Roger. Oh, and by the way, he did this kind of in his spare time. He was actually a physician. He built this up over 15, 20 years. So I imagine, well, if I were Roger in 2023, what would I do? to create something like this, because we have the kind of point lookup, the search engine thesaurus, where you can type in a word and get its synonyms, but how would I arrange the words bottom up? How could I find all of the words that were related to logical reasoning, for example? So the approach that we use there is to compute embeddings, sentence embeddings for each word sense in a vocabulary. I mean, roughly speaking, the sentence embedding model takes the word and the definition and computes a sentence embedding on the combination of things, and then clusters the embeddings. And then we get these clusters, and then we name them automatically by asking GPT. All of these words are related to the concept of blah. And it's a little more nuanced than that. We ask it a few times, and we ask it to pick its own favorite example from its choices. What we end up with, I'm just gonna, you've seen these kinds of scatter plots before. This is an interactive sentence embedding map for it's an interactive map of the clusters that are derived from this process. Okay, I'm just picking one randomly. So initially, these words, patriotic, chauvinist, chauvinism, jingo, these are all words related to patriotism. So our first step was to cluster those words in the first place and recognize that they're related to each other. And then the next step is to name that cluster patriotism with the technique that I just described. You can kind of see, like, if I move to different dots that are nearby, and if you have the link, you can kind of play with this yourself if you want. There's another kind of, like, extremism is here, which is a different cluster. Nationalism, which is very related, is there. And then you can see these are all in this pink area. This is probably like social systems. If I had to guess, all of these things relate in some ways to social systems. Let me, social systems, right. So we name the categories and then do this cluster, this further clustering of the clusters. And then I'm left with, after all of that, we're left with like 30 or so top level subjects, which we name by hand. And this appears on the front page of One Look Thesaurus, and it's a way of like indexing into words in the kind of original Roget fashion. But unlike, the original Roget had 1,000 categories and 15,000 words. This is more like 8,500 categories with 1 million to 2 million words. And the nice thing is you can get stuff that's just really, really, really out there. So as an example, within the math and astronomy subject, there's an entire, there's 2 categories that are just related to 3D polyhedra. And so if I want, let me just to show you, go there to see what that looks like. Math and astronomy, polyhedra. So here are several hundred terms, adjectives, and nouns related to polyhedra. So having them all in one place like this is helpful because I can then do the sorts of things that I've already described, like what are the funny sounding ones? It's not that funny. Dodecahedron, or what, or maybe alphabetize them, or further, or see what verbs and which ones are outdated, out of their adjectives, et cetera, et cetera. There's also this thing where you can like browse the categories and this visualization. Anyways, I think that takes us to our last application. So thank you. Blog. We have this blog that I only post to about once a year, but the last post has a nice recap of the co-op program we ran last semester. And I have some other discussion points.
Yeah, well, thank you. Thank you. So you had some discussion, right? You can tell us, is ChatGPT gonna take over the world? That's Jonas's question.
That is my question.
Yeah.
Just share with us, like, you've seen all this language stuff over like 20 plus years. And I know we've had a lot of conversations about your kind of thoughts on ChatGPT and all this. I'm just curious, yeah, like, what does it mean for us? Like, what's your advice to students in the world of ChatGPT? Yeah, also, anybody should ask questions. Feel free to.
Yeah, I mean, it's exciting. Overall, it's tremendously exciting. I think it's exciting the way maybe nuclear war is exciting. Like, like it's like, oh, it's an amazing power, but also like I'm really afraid of. I have like a whole portfolio of fears, short term to long term, about this stuff. But overall, I think it's good to be optimistic about technology, which is so obviously helpful to people, you know, at leveling playing fields, at helping people write who can't easily write, at helping people get, you know, learn and, you know, have this 24/7 always available, really, you know, competent tutor. I mean, I think it's all amazing stuff. So yeah, as far as in particular, there's this questions around how does that impact these kind of like brainstorming tools and ideation and creativity, and what does it mean if ChatGPT is the thing that if everyone's leaning on ChatGPT to write messages and poems and songs, like what happens to what happens to the quality of what's produced in the short term, but also like what happens to you if as you lean on it. So I have a lot of my concerns are around what happens to you, and in particular, I have this line in my talking points there, which is like, what's the line between assistance and enfeeblement? So assistance, I like to think of what the Datamuse sites do as kind of light assistance for creativity, right? But in a way, I feel like it's possible to go too far. Like over the years, the last few years, people have said, why don't you just add a poetry generator or something that, like, you know, uses these models to help people write poetry? And I think it's like, well, I don't really want people. I mean, people, that kind of suck. I'd rather help people, inspire people with ideas that they can use themselves, right, rather than do the thing for them. But there's right, yeah, I mean, it's a good question. I think I'm not an education researcher, but I believe that the writing process is important for the process, that you engage with ideas when you write, and that it helps your intellectual growth, and that it's just more pleasurable, I would say. Writing is like I find it to be a chore and hard, but it's also kind of pleasurable to produce something on your own. And also, I think in order to write, you need to read, and I'm worried about the whole incentive structure around reading and writing. I'm worried about that eroding as tools like ChatGPT are leaned on. It's not like a new fear, though, because people had the same fear about calculators and GPS units and all sorts of other technologies that replace cognitive skills. So, you know, we have those things, and we're still alive. So that's good.
Not really a question, more of a comment. I studied.
Sorry, give me a second. Do you mind muting and then unmuting?
Oh, sure.
Sure. No, it's just a comment. I studied linguistics and phonetics in undergrad, and now data. So seeing it like earlier in the presentation, seeing how you like broke it down, that was really cool, like really like fascinating. But back on the ChatGPT stuff, like I do think it's a tool. It's helped me a lot with understanding what code means, like in classes before, like since it's all open source, like they just tell you, like in the past, it's like, oh, here's your project, just Google how to do it. There's like Stack Overflow, but with ChatGPT, I've actually been like, what does that mean? And it explains it to me. And so now I feel like I have a better understanding of it. But I will say GPS, if people were afraid of that before, like I do have very bad sense of direction because I grew up with GPS. Like I've never had to look at a map and like figure out which street to take, you know what I mean? But you know, like I don't know. It's good and bad. Like I feel like I have a better understanding of things because of ChatGPT. Like I could just Google it It's just faster. I save so much more time just asking the questions.
So, yeah, yeah, on the GPS thing, I think it's this double-edged sword. It's been a double-edged sword for me because I think I am probably a little worse at getting around than I don't know. On the other hand, like the availability of Google Maps has also made me explore things in a way I didn't before, right? And so I find it like endlessly fun to like zoom around the 3D imagery on Google Maps or whatever. And so GPS, well, I guess that's not GPS, but it's all not related to the same thing. I think so with that technology, I can't say that GPS has caused me to be like more literate about my surroundings. So
Has not.
Yeah,
right.
so maybe that's a good thing. I don't know. Calculators. I mean, when I was in school, like graphing calculators were becoming popular, and like the fear was that, oh, if you don't, learn how to graph functions yourself, like, but then it turned out it's like, well, that's not something you really need to do most of the time in your adult life, but like writing and thinking and, communicating are things you need to do. So I do feel like it's like categorically different.
I just think like, honestly, like when will I be in a situation where I need, like, hypothetically, I should have better sense of direction if I ever get lost and I don't have a GPS. But for me, it's like, I could just bring a charger with me everywhere I go because I run a battery with my phone, like, instead of like learning direction or like, I've never been in a situation where I needed to have a better sense of like, that's north and that, like, you know what I mean? Like,
Yeah.
and same thing with a calculator, like in school too, like you can't use calculators, you won't use calculators in the real world. I don't know, I pull out my calculator to, you know what I mean? Like, it's always available. Like, I've never been in a situation where I'm like, dang it, I'm like, I should have like learned how to do this, like, I should have my multiplications table memorized, so like, I don't
On the
know.
other hand, phone numbers. I don't remember anyone's phone number.
Right, yeah.
That's true. That one's that, yeah. I mean, I remember the important ones because that's actually scary for me. I don't want to get lost without them. Whatever, I'll just charge my phone somewhere. Like I'm not gonna end up in the middle of nowhere.
Yeah.
And if I am, I'm probably gonna plan for it and write stuff down. You know what I mean? I don't know.
Then in the future, you're gonna need, if you wanna write something, you're gonna need to have, one of these models. So is that what you're going with?
I'm a journalist, right? And the one thing that does scare me is that I do a lot of writing and I'm scared that one day it'll just do it for us. But you still need a human behind it to fact. It can fact check that. You know what I mean? I mean, if it can at some point, like, I don't know, like.
Finance jobs as well, they're all at risk. Finance jobs that are going in creation, everything's at risk.
That's the thing
All
that's.
the jobs are at risk. When you say that it's also going to change the type of job in the market. You're gonna create new types of jobs and then take over a lot of old ones by finance jobs.
Yeah, I wish I knew. I have the same anxieties. I think, I think in the short term, like next 5 years, say, I can see just within even computers, tech jobs, people talk about it's like, oh, it's going to replace programmers. It's not going to, technology is not going to replace programmers per se, or any job. It replaces tasks, or it makes tasks easier. And so it may reduce the need for people to hire in certain job categories, which I guess is what people mean by replacing. But I would say for like the next 5-10 years, there's a lot of like exciting applications of this stuff. So for example, I listed on the slide here, it's like one thing that I could work on, I'm not necessarily inclined to, but like a poetry critique thing where like it helps people. It helps people in the same way that you use ChatGPT for learning a subject or sort of brainstorming about your writing. It could help people with poetry, when it could help on very specific ways, like it could help with theme development and meter and imagery and such. I think that would be cool. And that's just one application in my own little world. But then in any domain you think of right now, there's just as you've probably seen, there's how many hundreds, thousands of companies are being started around this stuff. And I think a lot of that's going to be very duplicative, but and will eventually be, swept away. Like a lot of the stuff that's, there's a bit of a, what's the word, not arms race, but gold rush. Yes, there's a gold rush right now. So there's a lot of insanity, but there are also legitimately going to be a lot of new things to work on. It's kind of like 10, 15 years from now. It's like kind of like boggles my mind trying to think about what stuff will be like. So, I mean, and I hope we're not all using ChatGPT to do all of our writing or whatever exists then, because it's like a bleak future that I don't want to live in.
Yeah.
Sorry.
I feel like a lot of people agree with that. I think that's reassuring.
You
You
know?
know, like I've seen a lot of those arguments too. I think the only people that use ChatGPT to do all of their writing are like high school students that don't want to do homework. You know, like to be honest, but I have met a lot of people that wouldn't want it to take over. Being able to think critically is important as well. I think a lot of people agree.
Right, and you hope that if enough people in society don't want something to happen, then we will find. Also, like one thing I'd say is that no matter how creative GPT-4 or the like are, and they can be really shockingly, they can do things that look very creative. The bar for creativity, hopefully, is going to be, this will be a bar raiser in the sense that like what is considered an interesting music for humans will maybe need to be more creative. Right?
Yeah.
So
Actually, that's a really, I never thought of it that way, but that's a pretty hopeful way of thinking about it, right? It's like when we worry about ChatGPT taking over, it's like implicitly our view of human capability or human aesthetic or whatever it is fixed, right? We're like, oh my God, this thing is doing all the things that we value or we can do now. But if you view it as evolving, then yeah, I think I mean, then maybe it's just a race. Like the LLMs are always catching up, trying to catch up to the humans, but that's interesting. I know we have a couple minutes. Did you wanna, you had some words of wisdom, I think, right? A slide of wisdom.
oh yeah, well actually first can I show this slide? This is I want to just to show that GPT-4, which if you haven't used it yet, you should try GPT-4, I guess, or Bing or whatever. Yeah, Nabeel and I used to get these chicken bao sandwiches at Dumpling Daughter in Cambridge, and so I wrote a little limerick, or can I say I wrote the limerick? I guess the computer wrote the limerick. The computer and I collaborated to write the following limerick. There once was a prof from Northeastern whose chicken sandwich love was a beastin'. In lectures, he'd munch between theories and lunch as the students all stared at the feastin'.
Really good.
It's pretty good. It's pretty good, right? I mean, Northeastern and a beastin' aren't perfect rhymes, but that's probably
I
better.
think Rhyme Zone would have done better. Perfect match. Yeah.
Oh, I don't know. Yeah, yeah, initially when you invited me to talk, I think we had talked about like words of wisdom or whatever. Well, I have this page of words of wisdom for people doing something similar, which is in life, which is to say working on websites or apps or consumer things, which by no means is the only thing to do in life. But if you happen to do that, just be aware, the internet is just incredibly large. Like there's just so much demand for stuff and information that even if you go niche, even if you just, kind of satisfy your own, like scratch your own itch, like you're interested in some very esoteric subject. Of course, you'd be surprised how many people out there share that interest, and developing tools or sites or stuff for those people is possible because it's so large, because the numerator is so large. Be patient. Give your ideas years to breathe. Yeah, I don't know. Like lots of stuff that I've worked on hasn't really panned out at all, and then other things just take a while to pan out. Treasure feedback from users. So everyone who writes to you or like a comment, you should upweight what they say by tens of thousands, because most people, if you think about how often you actually send feedback about a website, say it's just not that often. Most people, if they're taking the time, they usually mean well. I think the only two things that I feel like this fast response time matters more than people think. That has been studied formally, like Google had a blog post from 10 years ago, which showed that if they shave off a few tens of milliseconds from their search results page, the number of users increases, people come back and make queries more often, and people are happier. And it's really not appreciated in 2023. Like stuff seems to be getting slower somehow. But yeah, anyway, response time, very important. Feature discoverability. Yeah. Feature matters even more. So if you do something new, make sure, like, for example, I had this way on RhymeZone, there's this way of like sorting the thesaurus results by meter, which was buried in a couple of menus, and no one was using it until I just made a little call out and moved the feature into a more prominent space. And then suddenly there were like posts of people saying, wow, RhymeZone added this feature, but really I had added it years prior. Anyways, it's just discoverability matters a lot. Make sure that when you do something, just check the log, check to be sure that people are actually using it. I guess basic wisdom is like, you're always too immersed in your own work to see its flaws. So ask other people. People crave serendipity, not just, I really dislike the general trend of the Silicon Valley ethos of saving time, doing things more efficiently, it's like, where, to what end, like, why are we doing all this stuff to save our time? Like, I think a lot of people, and increasingly now that there are tools that do all the work kind of for us, people are going to be craving the amuse and muse part more. And then finally, Sam Altman has this advice about advice, which is ignore all advice. So you should heed that advice.
Except for Doug.
Yeah.
Thank you so much, Doug.
Right.
Thanks again. Thanks,
Cool.
everybody. We'll see you soon. Bye.